All right, guys, welcome. We are going to be taking a look at lesson 4-6. We're going to take a look at dividing complex numbers. Last week we had a chance to add, subtract, and multiply. Today we're going to get into dividing. A couple of reminders. Anytime we see that I squared, remember we're always going to be replacing that with our -1. That's still going to be in use today. And one other reminder is that we always want to express our answers in this A plus BI, where A is going to represent my real number, the BI is going to be my imaginary portion. So let's get started. The biggest rule for dividing is the fact that we're not really dividing, we're multiplying. I know that seems really weird, but the little watch out note is that I cannot be in the denominator of a complex number. So when I look at a question like number 1, I see 10 over 2i. I cannot have this I down at the bottom. And so to fix it, what I'm going to do is I'm going to multiply the top and the bottom by I. Class, when we multiply fractions, we're just going straight across. So we're going to have 10i at the top. At the bottom, 2i times I is 2i squared. And now I'm remembering my rule. Where I see that I squared, I replace it with -1. So I get 10i over 2, let me back that up, all over, here we go, 10i all over -2. And then the very last step that we'll do is we'll simplify. So 10 divided by -2 gives me a -5i. Right? So let's take a look at number 2. I've got 4 over -9 times I. Again, that problem is the I at the bottom. So we're going to multiply top and bottom by I, multiply straight across. 4 times I is 4i, -9i times I is -9i squared. We'll replace that I squared with a -1. So I get 4i all over +9. And then in this case, I can't simplify any further. 4 over 9, that does not simplify. So this is my final answer. So you can see, even though it's saying dividing, we're really just multiplying. I want you guys to take a moment, try number 3. You can pause the video, give it a try, and then replay it to see if you got your answer correct. Okay, so what I did was I started with a multiplying top and bottom by I squared. I multiplied straight across, so I had -7i over 5i squared. I'm replacing I squared with -1. So I ended up getting a -7i over a -5. Negative over negative gives me positive. So my final answer is 7 over 5i. So hopefully you guys got that. All right, let's take a look at number 4. It's still the same type of concept. I have an I at that bottom, so I've got to get rid of it. So I'm going to multiply the top by I and the bottom by I, just like we've done. One thing that you have to do is I'm going to put parentheses around that expression in the numerator because I'm going to need to distribute. I'm going to do 28 times I to get 28i, -8i times I to get -8i squared. At the bottom, you're doing 4i times I, so it's 4i squared. Now, let's go ahead and replace our I squared with -1. That's what we've been doing last week, and here we are again. So I'm going to get a 28i minus 8 times -1 all over 4 times -1. Well, we can simplify. So we get 28i plus 8. Plus 8 because your -8 times -1 gets you that +8. And then let's take a look at our denominator. We're going to have 4 times -1, so it's -4. The last thing, well, almost the last thing I want to do is simplify. If I look at these numbers, 28, 8, and 4, they're all divisible by a 4. So I'm dividing everything by 4. So I get 7i plus 2 all over negative 2. And that seems like it'd be a really great answer, but remember, it's got to be real first and then the imaginary. So I want to write this. I'm going to kind of do a switcheroo right here and make this 2 plus 7i over negative 2. And then sometimes they even break that fraction up. So 2 over negative 2, 7i over 2. 2 over negative 2 is negative 1. So this would be like the most simplified, real then imaginary. Okay. Let's try another one like this. So let's take a look at number 5. Same stuff, guys. You can't have an I at the bottom. So I'm going to begin by multiplying top and bottom by I. I'm putting parentheses around that numerator because I have to distribute. 1 times I is I. 4i times I is 4i squared. At the bottom, 2i times I is 2i squared. Let's replace our I squareds with that negative 1. So it's I plus 4 times negative 1 all over 2 times negative 1. 4 times negative 1 is negative 4. 2 times negative 1 is negative 2. Let's switch this order. I'm going to put the negative 4 first, and that I is positive all over negative 2. Break it up. Real, then imaginary. Simplify. So negative 4 over negative 2 is 2, and I'm just going to say minus I over 2 because that 2 at the bottom over here, that was a negative. So down here, I'm just saying minus I over 2. Okay, you guys take a moment and give number 6 a try. You can pause the video while you try it and then unpause just to check to see if you got it correct. All right, so taking a look at this one, I multiplied top and bottom by I. I had to put parentheses and distribute. So I had negative 8i minus 2i squared. At the bottom, 6i times I got me 6i squared. I'm replacing my I squareds with that negative 1. So you can see that here and here. I multiplied, so I got negative 8i plus 2 all over negative 6. From here, what I did was I just switched the order because remember, we want real, then imaginary. I broke it up into 2 fractions, and then I simplified from there. So my final answer is negative 1/3 plus 4i over 3. Okay. This became a positive here because we had this negative and a negative right there. That's how I got that to be plus. All right, moving on. We are going to take a look at different problems where you have what's called a binomial denominator. If you can see now, it's 5 minus I, 6 plus 2i. And so when this happens, you're going to multiply the top and the bottom by the complex conjugate. So reviewing that from last week, we saw complex conjugate is going to look like this: a plus bi times a minus bi. It's the same exact terms, just a different sign. And so like for number 7, to get rid of that I down there, since I have 5 minus I, I'm going to multiply top and bottom by 5 plus I. In the top, we're going to distribute. Negative 2 times 5, I get negative 10. Negative 2 times I get negative 2i. In the denominator, because these are complex conjugates, you could do that shortcut that I told you about. You don't need to do FOIL because the middle 2 terms are going to cancel out, so we can just do Florida, the first 2 terms and the last 2 terms. So I'm going to do 5 times 5, that's my first 2 terms, to get 25. And then I'll take the last terms. Negative I times I get negative I squared. Now we're going to do this just like we did those previous problems up above. We'll replace our I squared with a negative 1. So I'm going to have negative 10 minus 2i all over 25 minus negative 1. That becomes 25 plus 1. 25 plus 1 is going to be 26. Let's get this in standard form. Let's switch the real and the imaginary. So I'm going to put my, or sorry, it actually already is. All right, sorry. So now we're just going to simplify. We can divide everything by 2. So we can get negative 5 minus I over 13, and then break it up. Negative 5 over 13 minus I over 13. That's for that real and imaginary. So it's a little bit different than the ones up above, but same kind of concepts. If we look at number 8, we also are going to need to multiply top and bottom by the complex conjugate. So down at the bottom, it's 6 plus 2i. I'm going to switch it to make it 6 minus 2i. Notice I'm also putting parentheses around that. That just helps me out. Up in the top, we've got to distribute. So 5i times 6, I get 30i. 5i times negative 2i, I'm getting negative 10i squared. Down at the bottom, since that's that complex conjugate, we can shortcut. We can do Florida, first and last. 6 times 6, those are my first two terms. 2i times negative 2i, I get negative 4i squared. Okay, we are going to replace our I squareds with negative 1. So we're going to get 30i, here we go, 30i minus 10 times negative 1, all over 36 minus 4 times negative 1. Negative 10 times 1 is positive 10. Negative 4 times negative 1 is positive 4. So we can actually add the bottom. 36 and 4 is 40. We can simplify because 10 goes into everything. So 3i plus 1 over 4. And then let's make this real first, then imaginary. So I'm kind of just flip-flopping that order and then breaking it into two separate fractions. All right, guys, so on this back page 9 through 16, it's really more of the same type of questions. I'm going to go through and work out the odd ones. You can just kind of watch as I do it and fill out your notes for some additional practice. So taking a look at number 9, I need to multiply top and bottom by the complex conjugate of what's in the bottom. That's going to be 4 plus 3i. I'll distribute. 3i times 4 is 12i. 3i times 3i, I get 9i squared. Complex conjugates, we get to do Florida, our shortcut. 4 times 4 is 16. Negative 3i times 3i is negative 9i squared. I'm replacing my I squareds with negative 1. So I get 12i plus 9 times negative 1. 16 minus 9 times negative 1. So we get 12i minus 9 all over 16 plus 9. 16 plus 9 gets me 25. I'm going to switch this up. We'll make it real first, then imaginary. When you switch, guys, just make sure your signs are in the right order. And I don't think I'll be able to simplify with 9, 12, 25. Nothing goes into all of those. So I'm just going to say negative 9 over 25 plus 12i over 25. Real, then imaginary. Okay. Number 11 is pretty similar. When I go to do this complex conjugate, top and bottom, remember, it's just switching the sign in the middle. So I'm going to multiply top and bottom by negative 4 minus 8i. Let's distribute. 7i times negative 4, I get negative 28i. 7i times negative 8i, I get negative 56i squared. Complex conjugates, I get to do my little shortcut first and last. So negative 4 times negative 4 is 16. 8i times negative 8i, I get negative 64i squared. Let's replace I squared, negative 1. So we have negative 28i minus 56 times negative 1 all over 16 minus 64 times negative 1. So negative times a negative is positive. I'm just making that change now. Down in the denominator, let's go ahead and add 16 and 64. So I'm getting 80 at the bottom. What I'm also going to do, guys, in this step is just switch my real and imaginary. So I'll put 56 first and then negative 28i. Let's see, as far as simplifying goes, I believe 4 can go into everything. Sometimes you just have to check in your calculator to see what can go into stuff. So if I divide everything by 4, I end up getting 14 minus 7i over 20. And then I'm just going to break that up. 14 over 20 minus 7i over 20. Now, this part here, the 7i over 20, that can't be simplified anymore, 7 over 20, but 14 over 20 can. And so what I'm going to do to this is I'll just divide these by 2. So I'm going to end up getting 7 over 10 minus 7i over 20. We always want to simplify as far as possible and make it real than imaginary. Okay. All right, looking at number 13, multiply by the complex conjugate, 2 plus 4i. It's the same terms as what's in the denominator, I just switched the sign. Now, this problem becomes one of our biggest problems, 13 and 15, because up at the top, I've got 2 binomials. So at the top, I do need to FOIL. So my first 2 terms, 1 times 2 is 2. Outer terms, 1 times 4i is 4i. Inner terms, 8i times 2 is 16i. And then my last 2, 8i times 4i, I get 32i squared. That makes it a little longer. Now the bottom, because you have your complex conjugates, that's when you can shortcut. Florida. 2 times 2 is 4. Negative 4i times 4i, I get negative 16i squared. Okay, so in my numerator, I'm going to do a couple of things. I'm going to combine my like terms, and then I'm also going to replace that I squared with negative 1, which that's been standard for every problem we've seen today. So 2 changes coming now. I'm going to make this 2 plus 20i plus 32 times negative 1 all over 4 minus 16 times negative 1. I'll do the multiplication with that negative 1. So 32 times negative 1, I get negative 32. Negative 16 times negative 1, I get positive 16. I'm going to combine like terms in the numerator. 2 minus 32, I get negative 30. 4 plus 16, we get 20. Let's simplify. Let's divide everything by 10. So I get negative 3 plus 2i all over 2. I'm already in real and imaginary. I'm just going to break it up. Negative 3 over 2, 2i over 2. We can't simplify negative 3 over 2, but I could simplify this. 2 over 2 is 1, so it's just going to be I, 1i or I. So the simplifying part is a little different because you do need to kind of look at each question individually to see if you can simplify stuff. All right, last one. We're going to multiply top and bottom by our complex conjugate, 5 minus 5i. Same terms, just a different sign. This also becomes a little bit of a longer problem because in my numerator, I have to FOIL. 9 times 5 is 45. 9 times negative 5i is negative 45i. 6i times 5, I have 30i. And finally, 6i times negative 5i, I get negative 30i squared. The denominator is a little bit easier because we have those complex conjugates. We could just do first and last. So 5 times 5 is 25. Oops, I don't need to do that, sorry. And then I'm gonna do the last two terms. 5i times negative 5i, negative 25i squared. So we're going to begin to simplify. We know I squared will be negative 1, but in this case, I'm also going to combine those like terms in my numerator. So for the numerator, it's going to be 45 minus 15i minus 30 times negative 1. My denominator is 25 minus 25 times negative 1. And I'm just going to begin this process of multiplying my negative 30 times negative 1 to get positive 30. Negative 25 times negative 1 to get positive 25. Combining like terms in the numerator. So 45 and 30 is 75. In the denominator, 25 and 25 is 50. We will be able to break this up. I'm going to do 75 over 50 minus 15i over 50. And now I'm going to simplify each fraction. I kind of broke it up first because here we can divide by 25 and here we can only divide by 5. So I'll get 3 over 2 minus 3i over 10. Real then imaginary simplified. All right, guys, go ahead and start your practice, and I will see you tomorrow.